All right, so we're going to talk about the imaginary unit today, which is I. Normally when we take square roots of numbers, they're always positive numbers. Imaginary units were invented to deal with some equations that can't be solved with regular numbers. They're not actually imaginary, which we've talked about. So I, it represents the square root of -1. They call that the imaginary unit. So I is like 1, but for imaginary numbers. So because it's the square root of -1, if I squared it, you'd have the square root of -1 times -1, and you'd have that pair of negative ones to be -1 squared. So if I square I get -1. So these are the two facts that you need to know about I to do pretty much everything we're going to do with imaginary numbers. So when we are simplifying square roots that have a negative on the inside, this is only when they're on the inside, there's just a little extra step. So what we do is we separate this out. -4, we're going to make it the square root of 4 times the square root of -1. So we're sort of using that multiplication rule backwards. So the square root of 4 we can do. 4 is just 2 times 2. So that's going to be 2. And the square root of -1 we just defined as I. So we're going to get 2I. So it's just like taking the square root of 4, but you add an I on. So if there's a negative underneath there, basically it's going to add an I to your answer. So the square root of -16, we could think of as the square root of 16 times the square root of -1. What's the square root of 16?
4.
4. So this would be 4I. So if we do -36, it's the square root of 36 times the square root of -1. What's the square root of 36?
36.
What times itself makes 36?
6.
So this would be 6, square root of -1's I. So you get 6I. So these are ones we might know offhand. You can also do your prime factoring, the birthday cake method that we did, to figure out what those numbers are. But these were all perfect square numbers, and that's why we came out with just no radicals in the answer. However, 12 is not going to work that way. We can still separate it into the square root of 12 and the square root of -1. But 12 is not going to be as easily square rooted, so we are going to factor it. So birthday cake method. So take the 12. What prime number do you want to divide by? 2. We get 6. Let's do 2 again. We get 3. Divide by 3. We get 1. So there's our candle on the birthday cake. We know we're done. So 2 times 2 times 3. So I have a pair of 2's. So that means this is 2 square root of 3. And then this is I. Now this is the part that's a little weird. They don't like putting I after the square root because sometimes it looks like it's in the square root, which is really bizarre. So they'll take this I and they'll put it with the 2 in front of the square root and call it 2I square root of 3. That's typically how you're going to see that. They don't like putting the I on the end. I don't know who makes these things up, but that's just how it works. Okay? So a lot of this is similar to what we did with square roots and simplifying square roots. We're just adding a little bit of extra into it with the i's. So what these are used for, the kinds of equations you can use are these types of equations. If I have x squared equals -25, what do you do to get rid of x squared?
Divide by 2. Divide by
Square root it.
Multiply by 7.
Trying to help you guys out. So square root both sides. That gives you x. And then I have the square root of -25, which is square root of 25 times the square root of -1. The square root of 25 is just 5 times 5. So that's going to be 5. The square root of -1, we defined up here, is I. So we just get 5I. So if I have x squared equals -9, I can square root both sides. I get x. And then I just have the square root of -9, which is going to be the square root of 9, times the square root of -1. So what's that going to be?
9i.
So not 9. What's the square root of 9?
3.
So it'll be 3 times 3, so we get 3i. So make sure you're actually taking the square root of that number. All right, so then let's do this last one. X squared equals -8. So to get rid of a square, we square root. That part we've been doing since 8th grade, but the i's are the new thing. So this would be the square root of 8 times the square root of -1. 8 is not a perfect square, so we could take it to the side and use the birthday cake method to factor it. So we're going to divide by 2, get 4. Divide by 2, we get 2. Divide by 2, we get 1. We know we're done. And we take a pair of 2's to make 2 squared. Square root that, you get a 2 on the outside. There'll still be a 2 on the inside. And then the square root of -1 would be I. So we stick that in front of the square root. So essentially, if you can simplify square roots, it's just adding an I to the mix for this first part. All right, so down below, we're going to do some operations with I. So we're going to start by looking at powers of I. I have seen these on standardized tests before. They'll go, evaluate I to the 27th power, and you're like, I don't know what I is. Well, now you'll know, and there's a quick little way to figure this out. So I to the first is just I. I to the second is I times I, so if you think about that, it's the square root of -1 times the square root of -1. We talked about that at the beginning. You're just going to get -1.
You move it over a little
Oh, I'm
bit.
sorry. There you go.
Thanks. Oh.
So you get -1, which, so these two we already had. And then if I multiply it by another I, essentially this is going to be -1 times I, and you get -I. And then to do to the 4th power, I'd have -I times another I, which means I'm going to have -1, which is 1. And then the pattern starts over. So if I go to the 5th power, I'm just going to get I again. 6th power is -1. 7th power is -I. 8th power is 1. So it's going to cycle through 4 answers at a time. So over here, it's just going to go I, -1, -I, 1. So there is a way to quickly figure out if I gave you the 573rd power of I, and you're like, well, I don't want to make my table go that far. There is a way to figure it out, and we do it by dividing by 4 using a little long division. So divide the power of I by 4 if the answer is 1, if the remainder is 0. So if it divides evenly, then your answer is going to be 1. So you can see that when we had the 4th power, 8th power, 12th power, those are all divisible by 4. The answer is I if the remainder is 1, because then you would take 1 times I. The answer is -I if the remainder is 2, and it's -I if the remainder is 3. So this is just coming from this pattern that we saw up here. So if I have I to the 100th power, I'm going to take 100, divide it by 4. You probably know what that one is. Take $1, break it into 4, you get 25. And that would be a remainder of 0. 25 times 4 is 100. You get 0. So since the remainder is 0, that means it divided evenly. Your answer to that is 1. You get I to the 50th. We would divide 50 by 4. It does not go in evenly. 4 goes into 5 one time. 1 times 4 is 4. Subtract 5 times 4 is, or excuse me, 5 minus 1. 5 minus 4 is 1. I'll get it out eventually. Bring down the 0. 4 goes into 10 how many times?
Twice.
2 times. 2 times 4 is 8. And so our remainder, what's left over, is 2. So that means it's going to be -1. And then if you get to the 103rd power, if we divide that by 4, 4 goes into 10 twice. 2 times 4 is 8. Subtract, bring down the 3, we get 23. 4 goes into 23, 25. I'm sorry, 5 times. 5 times 4 is 20. Subtract, and we get a remainder of 3. So if the remainder is 3, it's -I. These questions also show up in high school knowledge bowl sometimes. They will say I and give you a power, and if you forget exactly what these 4 things are, there's only 4 choices. You could buzz in and say 1I, -1I, you'd have a 1 in 4 chance of getting it right.
So it's always I, never any other variable.
Nope. I stands for imaginary, unless you are actually becoming an electrician, and I in science stands for current, so they use J instead.
Jolts.
I know. Well, it's a lowercase j. I don't know why they can't just use lowercase I. I don't know. That's just what I was told. I have a friend that's an electrician, and they're like, we call it J. And I'm like, good for you. All right, so let's go down and just look at some other operations of multiplying some things with I. So you start this just pretending like it's an X. So if I have 3I times 8I, you take 3 times 8, which is how much?
16. That's not right. 24.
24. And then I times I is I squared. Now I squared, we've established in a couple of different places, is -1. So when you get an I squared, we're going to substitute in -1. So it's 24 times -1, which is -24. So essentially when you get that I squared, it's going to change the sign on your answer. So on the next one, if I take -7 times 2, I get -14. I times I is I squared. So this would be -14 times -1, which makes it +14. Now, just to confuse you, I put this, and it's just 2 times 7i. Since there's not another I, that's just 14i. That's it. There's no distribution because there's no plus or minus sign in here. This is one term. 7i is one term. So you just have to multiply the 2 by the coefficient 7. Call it good. All right, so down here, I have -3i times -4i. So -3 times -4 would be +12, and then I times I is I squared. So this would be 12 times -1, and we get -12. So when they have 3i in parentheses squared, that basically means we're going to take 3i times 3i, and a lot of people like writing that out because then it makes more sense to them, because I then go, oh, 3 times 3 is 9, I times I is I squared, which means 9 times -1, so my answer is -9. So when you see that squared, I would actually write that out and just make it into that multiplication problem. So over here, -5i would be squared, would be -5i times -5i. So -5 times -5 is 25. We have I squared, take I times I. So 25 times -1 is -25. And that is the end of the lesson.